for number 5, we have a radical equation. We have the fourth root of t minus 2 plus 8 equals 0. So to solve this kind of thing, to solve this kind of thing, we've got to get keep the radical on one side and have the numbers on the other side, the constants on the other. So with fourth root of t minus 2 plus 8 equals 0, we're going to add a negative 8 to both sides, giving us the fourth root of t minus 2 equaling a negative 8. Okay, so if we put each side to the fourth power, we're going to get t minus 2 equals then a negative 8 to the fourth power, 4096. Okay, then we add 2 to both sides, and we get t equals 4098. Okay, so now we try that in the equation. And if we put, just to check, we've got to check this thing. So if we have the fourth root of 4098 minus 2, and that equals a negative 8. Let's solve it. So we get the fourth root of 4096. And let's see if that equals a negative. Well, of course it can't equal a negative 8. It's got to be positive because it's an even root, right? And of course the even root of that is 8, and 8 does not equal a negative 8. Actually, I should have seen this right here. The root of t minus, the fourth root of t minus 2 has to be a positive number. So that's D, no solution. But let's try another one, another form of this. Okay, we have x equals the square root of x plus 4 plus 2. Okay, so we'll add a negative 2 to both sides, and we get x minus 2 equals the square root of x plus 4. Okay, then we square both sides, and we get x minus 2 squared, which is x squared minus 4x plus 4 equals x plus 4. Okay, and then if we add a negative x to both sides, we get x squared minus 5x plus 4 equals 4. And if we add a negative 4 to both sides, we see that the 4 goes away, and we get x squared minus 5x equals 0. And so we don't have to, it's easy. This is an easy one to factor. We'll factor out an x, and we get x minus 5 equals 0. So it's either x equals 0 or x minus 5 equals 0. And if we add 5 to both sides, we get x equals 5. So our two choices are 0 and 5. But in these situations where we end up squaring both sides, we've got to go check and make sure that both of them work. Because what's inside the radical can cause us a problem. Anyway, let's try them both. Okay, so if it's 0, if x is 0, it's 0 equals square root of 0 plus 4 plus 2. Okay, that's plus 2. Okay, so 0 equals square root of 4. 0 plus 4 is 4, so the square root of that is 2, and then it's plus 2. So 0 doesn't equal 4, so that doesn't work. Okay, let's try the other one. let's try 5 equals the square root of 5 plus 4 plus 2. Okay, so 5 equals square root of 9 plus 2, which is 5 equals 3 plus 2. 5 equals 5. We're good. So the only one that works is 5. 5 is our answer. Number 6. Alright, it's x plus 9 squared equals 12. And it looks like we're going to be using the quadratic formula, because notice in the answers, all of the answers have a radical. And plus or minus, right? So that's a good sign. Alright. However, there's a couple different ways to do it, but let's just do it one way. Let me get started. So x plus 9 squared would be x squared plus 18x plus 81 equals 12. Okay, and we subtract 12 from both sides. And I'm not recommending we do it this way, but I just thought it wouldn't hurt to show this way of doing it. So we've got quadratic form is negative b plus or minus square root b squared minus 4ac over 2a. So negative b, negative 18 plus or minus the square root of b squared, 18 squared. So we get negative 18 plus or minus square root of 324 minus 4 times 1 times 69, all divided by 2. So we have a negative 18 plus or minus square root of 48 divided by 2. Did I just say that? So simplifying the radical, it's the square root of 16 times 3, so we can pull a 4 out of there. And we get negative 18 plus or minus 4 times square root of 3 divided by 2. And then we can divide the 2 into the negative 18 and into the 4, and we get a negative 9 plus or minus 2 times the square root of 3. And that's our answer. Like I said, that's the hard way to do it. I just wanted to demonstrate the use of the quadratic formula. Quadratic formula. But here's how this problem should be done. Let me get a different color here. Okay. You always want to do it the easiest way possible. Whoops. So we have x plus 9 squared equals 12. So we just take the square root of both sides, and we get x plus 9 equals a plus or minus square root of 12. Okay, and then we'll add a negative 9 to both sides, and so we have x equals a negative 9 plus or minus square root of 12. And then we simplify the square root of 12. Times 3, and so we can pull a 2 out, so we end up with negative 9 plus or minus 2 times the square root of 3. So I'm not recommending that you do it the quadratic formula way unless you absolutely have to, but we notice that we get the same answer either way we do it. Number 7. Use the discriminant to determine whether the following equations have solutions that are two different rational solutions, two different irrational solutions, exactly one rational solution, or two different imaginary solutions. Okay, those are the possibilities. Okay, so first thing, the discriminant comes from the quadratic formula. So first thing we have to do is put our equation into the right form. Ax squared plus bx plus c equals 0. Alright, so we would do that. 5z squared minus 6z, we'll subtract 6z from both sides, plus 3 equals 0. Now remember the quadratic formula which we just used, negative b plus or minus square root of b squared minus 4ac divided by 2a. Okay, but the discriminant part is this part here, just this, b squared minus 4ac. So that's what tells us what kind of roots we're going to get. For instance, if the discriminant equals 0, then notice that the only thing we'll have is this. So we'll just have one rational solution, right? If the discriminant is a perfect square, like 16, then we're going to have two rational solutions. If the discriminant is not a perfect square, like let's say it's 28, well then we're going to have two irrational solutions, because we have this plus or minus thing here, and so if this is the square root of 28, we would and the square root of any number that's not a perfect square is an irrational solution, so we would have two irrational solutions. And then the last possibility is if we had a square root of like negative something, negative 5 for instance, well then that's an imaginary number. So we would get, because of this plus or minus thing, we'll get two imaginary solutions. So that's how we can test to see what kind of solutions we're going to get. So we just take b squared, so it would be negative 6 squared minus 4 times ac. A is 5, c is 3. So we multiply this out and we get 36 minus 20 times 3 is minus 60. And if we subtract that, we get a negative 24. See, so the square root of negative 24 is imaginary. So we're going to get two imaginary roots. Two imaginary. Which is that one right there, C. Number 8. Given that log 2 is approximately 0.301 and log 3 is approximately 0.477, find the following. Round your answer to 3 decimal places if necessary. Okay, well, this is actually quite a deceptively simple problem, but we'll see if I can try to do it the hard way first. Why? You're wondering why? Why? Because I'm always telling you to do it the easiest way possible. Well, I don't know, I think it'll be fun this way. So, we've got log base 9 of 27. Okay, so you notice up here in the answers for different logarithms, they have the base 10 log, not the base 9 log. So you could work this so that you get it into the terms of either the base 2 log or the base 3 log up above. One way to do that is use that principle where there's like a division of 2 logs. This log base 9 of 27 can be written like this. It can be solved like this. The base 10 log, the common log of 27 divided by the common log of 9. That'll give you the same answer. Now the log of 27 is also the log of 3 to the 3rd power. And the log of 9 is also 3 to the 2nd power. And using that exponent rule, we can change this into 3 log of 3 divided by 2 log of 3. Now here you can see there's two options right here. See, we have what the log of 3 is up here. In a way we don't need it, because the log of 3 divided by the log of 3 is 1. Anything divided by itself is 1. But let's just pretend we don't know that. And so we have the log of 3, so it would be 3 times 0.477. That's the log of 3. And then we have 2 times 0.477. But as you see, when we come to work this out, there's no point in multiplying these out because we can just cross-cancel those two. So we get 3 over 2, or 1.5, which in decimals is 1.5. Okay, and so we could also go back, if we went back up here and we just cross-canceled those two, log 3 into log 3, we still get the same thing, 3 divided by 2. Okay, so that's one way to do it. Okay, another way to do it, we have log base 9 of 27. Okay, so let's change this into log 3 to the third, log of 3 to the third base 9, right? Which becomes 3 log base 9 of 3. Alright, so this, trying to get that color, this part right here, not the log of base 9 of 3's, 9 to what power is 3? Well, it's to the 1/2 power, right? So the answer to log base 9 of 3 is 1/2. So this equals 3 times 1/2. Again, we have 3 halves, which equals 1.5. Okay, and now there's one more way to do it that's even easier than that. And that was pretty easy, don't you think? Okay, the last method I'm going to mention, which is the easiest, and almost like cheating, except that you're allowed to use your graphing calculator on the test, is that you look it up on the graphing calculator. You go into catalog, which would be second catalog. It's down by where the 0 is. It's where the 0 is. So you go second catalog, and then you push the L key, which is it's the same one as the closed paren, and that'll take you to the L's in the catalog. And then you go down, you search down until you get to this one, log base, with an open paren like this. Okay, so now if you push enter when you see that, what you're going to get is this. You're going to get log, and you're going to get a blinking cursor right here, and then you're going to get this. And you put 9 into the blinking cursor, that gives you 9 in here. I can't even put it in. Okay, so you put 9 into the blinking cursor, then it stops blinking, and then you go right arrow. So then you go, let's see if I can make a picture of the right arrow. You push the right arrow on your thing, and then this one starts blinking. And in that one, you put 27, right? See, so you've just taken this and fed it into the calculator. And then you press enter. And what pops out but 1.5. So, nice, easy problem. And so, we're finished, and I bid you aloha, and you have to decide whether I mean hello or goodbye.